Okay, so when we were talking about operations of functions, okay, we've already done sum and difference. And we talked about if you're given one function and another function and asked to add them, you just add them together and use algebra to simplify it. Same way with subtracting. And then for graphing them, if you're given the graph of one, the graph of the other, you pick common x values, you pick x values each graph has in common, find the y values and add the y values together, or subtract. Same idea with multiplying and dividing. Okay? So if you want to create a new function h of x, by multiplying some function f of x times some other function g of x, you just use a dot. That means multiplication. It may also look like this. Both of those mean the same thing. It just means take function f and function g and multiply them by each other. For division, remember quotient is the answer in the division. We take f of x, some function, divide some other function. So it'll look like that. Or you may see this notation, where it looks like that. So if you see this one, it's multiplication. If you see this one, it's division. Okay? Okay. So we've got two functions, x plus 2 and then minus 5. And then 3x minus 4 for g, we're asked to multiply the two of them together. So all that means is you take, and remember, we're going to plug them in parentheses. So I'm going to plug function f in here, in a big set of parentheses, and I'm going to plug function g in there. Is there an easier way to say this? X plus 2 minus 5. Can't I just combine these? What's 2 minus 5? Negative 3, thank you. Well, you guys know how to multiply those together. You do 4 multiplications, right? So it's going to be this, this. So that gives you 3x squared minus 4x minus 9x plus 12, which simplifies to 3x squared minus 13x plus 12. To answer part B, what's the domain? Well, there's a couple ways you could look at this. There's no square root in here, is there? So if you graph this function, it would be a line. What's the domain of any line? Doesn't a line go everywhere forever? So what's the domain of any line? What's the range of any line? Right, so what would be, if I multiply them by each other, what do you think the domain of the answer would be? What makes sense? Everything, right? Like if function f, the domain is everything, and function g, the domain is everything, then the function of f times g must be everything, which makes sense because what kind of graph is this? This is a parabola. What's the domain of any parabola? Left and right forever. So the domain, putting all these things in. So the domain of f of x, because it's a line, is negative infinity to positive infinity. The domain of g of x, which is also a line, is also negative infinity to positive infinity. So therefore, f of x times g of x the domain will be everything as well. Okay. And we confirm that because the answer to the multiplication is a quadratic, and the domain of any quadratic is always everything. Negative infinity to positive infinity. Okay, example 2. This time we're going to divide. So that means it's going to look like this when I plug it in. Oh, sorry, I plugged it in the wrong way. It's g over f, not f over g. So minus 2. How do we divide this? Well, often what you can do when you divide expressions like this, we can divide by factoring. We did this in grade 11, where we factored the top and bottom and we canceled out anything that was in common. Well, I can't factor the numerator, but I can factor the denominator. This is one of those trinomials. Anybody tell me the factor? X minus 2, x plus 3 is correct. And notice now that I can reduce these down to 1 and 1. So my simplified answer is 1 over x minus 3.
You have to keep the brackets?
Not necessarily, no. I always like to keep them to remind myself that they have to stay together, but it doesn't matter. It is x plus 3, because I made an error. Thank you for, yes, you're right. Okay. This is a little different, the domain, because you can't use the same argument here with division. Because if this function doesn't have an x squared, it would be a line with a graph. This would be a parabola. Domain of a line is everything. Domain of a parabola is everything. So you would think that when we divide, that it's everything. But it's not quite everything, because remember when we have fractions, there are some non-permissible values. There are some values that x can't be. Okay. So before I cancel this, what value of x would make this 0? 2. I can't, and if this is 0, doesn't matter what this is, 0 times this is 0, and I can't divide 0, can I? So 2 can't be part of my domain. What value of x would make this 0? That can't be part of my domain. So it's everything, because this is everything and this is everything, except because it's in fraction form, it can't be these two domain values. So how do I write that? Everything except 2 and -3. It's hard to write using interval notation. We did do it last year. Everything except 2 and -3 would look like this. X cannot equal 2 and -3. Because when x squared plus x minus 6 is in a denominator, because we're dividing, that means NPVs, non-permissible values, will kick in. There will be non-permissible values for x. So it's a little different with division. Because remember, with division comes non-permissible values. Okay. How do we graph a multiplication? We're not going to graph a division. But graphing the division is actually a little bit more challenging than it initially appears. So remember what we did with addition and subtraction. We have to find the common, the common parts of both graphs, right? So for example, the furthest left for each graph is here, when x is 1. What's the value of x here? -6. I can't do this one, can I? Because g of x doesn't extend. So between here and here are where the values are, where the graphs are the same. If any of the graphs extend outside either way and the other one doesn't, I can't do it. Like you can't multiply this one by the y value of g of x because there is no y value of g of x. So what are our x values? Our x values are -6, -3, 0, and 3. So what's the value of y in f of x when at -6? 4 times the value of g of x when x is -6. What's the value of y here? -1 gives me -4. So that means -6, -4. It's going to be down there. And I do the same thing. What's the y value for at x equals -3 in f of x? What's the y value here? 4 times the y value of this one gives me -8. So -3, -8. This is what my graph looks like so far. At 0, the y value in this graph is 1 times the y value in the other graph, which is -2, gives me an answer of -2. So 0, -2. And finally, when x is 3, the value of this one is 1 times the value of the y value of the other graph at x equals 3, which is -3, which gives me -3. So it's the same. So that funky looking thing is the graph when I multiply function f by function g.